Solve systems of linear equations in three variables. Okay, so our objective here, we want to solve systems of linear equations in three variables by eliminating variables. That's kind of the methodology here. We've already worked with systems of linear equations in two variables. This is somewhat similar, as we'll see. So what do we know? We know what a linear system is. It's two or more linear equations working together. Those equations are often written in the general form, but you could see them written in the y equals or x equals, or in this case, z equals form. So here's an example of a system of linear equations in three variables, x, y, z, the general form. Okay, as I mentioned, solving a linear system in three variables is similar to solving a linear system in two variables. What do we do? Let's take a look at the steps here, and then we'll go through one problem. The goal becomes, let's first reduce the system to two equations in two unknowns, or two variables, by taking two different pairs of equations, and usually we'll use the addition method to eliminate the same variable. So up here, we have three equations in three unknowns. Our goal is to get it down to two equations and two unknowns. Why? Because step 2 says we've already done that. We solved that system of two equations and two unknowns, and we know we can use graphing, we can use addition, or we can use substitution. Generally, again, we're probably going to be looking at addition. It tends to be the easiest method, but we know how to solve, we've seen how to solve a linear system of two equations and two unknowns. And then, as we saw before, we simply back substitute, work our way backwards to find the other unknowns. And then, of course, as always, we have a proposed solution, and we can check our solution in all three of our equations to see if it indeed works for all three and is indeed our solution. Let's take a look. This takes a little bit of time, not too bad. Definitely takes some space, which is why I've given you some space on you're going to want another piece of paper as well. There's not enough space at the bottom of this piece of paper. We're going to have to go to another piece of paper because it does take a little bit of time and space. Okay, example 1, we're going to solve the system. And we've got these three linear equations. Again, I'm going to label them equations 1, 2, and 3 so that I can refer to them. What we want to do is we want to eliminate, okay, we want to reduce this to two equations and two unknowns by eliminating the same variable. We need to do that twice, okay? So I'm going to choose to eliminate z. If I look here at these, elimination, I see equation 1 and 2. I just need to multiply equation 2 by 2, and I eliminate z fairly easily. That's the easiest one to see quickly that I can eliminate. So let's do that. I'm going to start off, it doesn't matter. I'm going to start off by, let's eliminate EL, how about ELI is eliminate. Let's eliminate IMAN. Wow, my spelling is not going too well at the moment. Eliminate, INATE. There we go. Let's eliminate Z. Okay, so we want to take, up here, we want to take two different pairs of equations. Okay, so my first pair, I'm going to take 1 and 2. I'm going to take equations 1 and 2, which means equation 1 is 5x minus 2y minus 4z is equal to 3. And equation number 2 is 3x plus 3y plus 2z is equal to negative 3. And my goal is to eliminate z. Well, how do I do that? Well, I'm going to multiply equation 2 by positive 2, because then these two coefficients will be opposites and I will eliminate z. So I have no change in equation number 1, it's going to be 5x minus 2y minus 4z is equal to 3. I am going to multiply equation 2 by 2. And I get 6x. I got to make sure I got to keep track of my math here. If I make a mistake, things will go really awry. Plus 6y plus 4z, there's my opposite coefficients, is equal to negative 6. And now I can use addition. And again, we know that that goes. So I've eliminated z. And my resulting equation just has x's and y's. 11x plus 4y is equal to negative 3. And I'm going to call this equation number 4. Notice equation number 4 is an equation that has two unknowns because we got rid of the z. So there's my first equation in two unknowns. I need a second equation in two unknowns in order to move forward. So I'm now going to take equations 2 and 3. I could take 1 and 3 if I wanted to. I'm going to take 2 and 3. And again, I'm going to work to eliminate z from 2 and 3. So let's take equations 2 and 3. And those equations are 3x plus 3y plus 2z is equal to negative 3. That's equation 2. Equation 3 is negative 2x plus 5y plus 3z. And again, I'm being careful because it's easy to make a mistake somewhere. Okay, I want to eliminate z again. I'm going to multiply looking at 2 and 3, the lowest common multiple is 6. I'm going to multiply the first equation times negative 3 to make it the opposite. And I'm going to multiply the second equation by positive 2. So I have a negative 6 and a positive 6 as coefficients to my z variable. Okay, let's see. We get negative 9x minus 9y minus 6z is equal to positive 9. And we get negative 4x plus 5y plus 6z, I hope, yeah, sure enough, is equal to 6. So again, the goal was to, when I add, the goal was to eliminate z. And there we have z's as opposites. Negative 9x and negative 4x is negative 13x. Negative 9y and 5y is just a, whoops, I goofed. I knew it. Good thing I did this beforehand. 2 times 5 is 10. I knew I goofed. You gotta be careful. I bet you all were thinking, he goofed. Hey, go back. That's a 10y. I did goof. Negative 4, 10, 6, and 6. Okay. Negative 9y and 10y is positive y, and 9 and 6 is 15. This, I'll call this one equation number 5. So now I have two equations in two unknowns, which we've worked with before. We can solve that. So let's make a note of that. We got equations 4 and 5. Okay, we have two equations in two unknowns. And we can work with that. Okay, let's get this. Let's continue on another piece of paper. Maybe the back side of your paper, maybe another piece of paper. We have more work to do. I'm glad I caught that mistake. Okay, starting off. Okay, I'm going to first write those two equations down. So I'm going to just make a note here that the two equations, because they were on the other piece of paper, I want to see them here. So let's make sure I get these written down correctly. Equals negative 3. This was equation 4 that we just came up with, and equation 5 was negative 13x plus y is equal to 15. Okay, so now we can use substitution, addition, or graphing. I'm going to use addition again because I notice that if I multiply equation 5 by -4, my y's will have opposite coefficients. Their sum will be 0, and I will have solved for x. So I'm going to use addition again to, I'm going to spell eliminate correctly this time, I hope, to eliminate y. It's just my choice. You could work with x, you could change them to y equals and graph them. You could solve for y in this one and substitute, your choice. I'm just choosing to use addition again, but there are other ways of doing this. So I'm going to write the equations down again. A fair amount of rewriting on my part just to make sure that things are clear for you on your end. Okay, now I know what I'm going to have happen. I know that for the equation number 4 here, there will be no change. And for equation number 5, I want to multiply it by -4 so that I can get it, I'll get a 0 when I add up my y's. So I have 11x plus 4y equals -3. And times 4, oh my goodness, I gotta get my calculator out. -4 times -13 is +52. -4 times 1 is -4. There we go, that's my opposite coefficients. And -4 times 15 is -60. Now let's add. There's my 0 for my y's, so I've eliminated my y's. 52 plus 11 is 63 x's, and 3 minus 60 is -63, and so divide both sides by 63, and x equals -1. There we go. So all of that work from 3 to 2, from 2 to 1, got me to know that x is equal to -1. So now it's time to back substitute. Okay, so I'm going to back substitute. Let's go backwards and solve for y and z. So back substitute. And we know that x equals, we think x equals -1. X equals -1. We want to back substitute this into either equation 4 or 5. One of these two, and it'll help us find y. It'll get us to find y. Okay, so we're going to just work our way backwards now. We worked down to here. Now we're going to go back up and back substitute to get y and z. Okay, we can choose either 4 or 5. I'm going to choose 4. There's no reason I'm choosing 4. I just decided that would be my choice. So 4 says 11 times x, and we think x is -1, plus 4 times y equals -3. Let's solve it. This is -11 plus 4y equals -3. I'll add 11 to both sides. 4y is equal to 8. I'll divide both sides by 4. And I just found y. Y is equal to 2. Slide it up. Okay, now we're going to back substitute into one of our original equations. Okay, now we have x. Now we have y. We got to back substitute in for z. So I'm going to back substitute. Now I have x equals -1 and y equals 2 into, well, we can choose either equation 1, equation 2, or equation 3, one of our original equations, which has all 3 variables. And we want to find z. Okay. In this case, I chose equation 1. Equation 1, I'll remind you from the front, equation 1 was 5x minus 2y minus 4z is equal to 3. Again, you can choose equation 2, you can choose equation 3. It should give you the same answers. I happen to just choose equation 1. Now let's substitute. So it's 5 times -1 minus 2 times 2 minus 4 times z is equal to 3. Do some math. This is -5 minus 4 minus 4z is equal to 3. Well, -5 minus 4 is -9. Minus 4z is equal to 3. Add 9 to both sides. And we got -4z is equal to 12. Divide both sides by -4. And we got z is equal to -3. I almost lost you on the paper. Okay, so z is equal to -3. So we think we know the solution. Our proposed solution, we have, let me slide up here for you. We have x is -1, we have y is 2, and as I slide the paper up a little bit, z is -3. So our proposed solution is the ordered triple, -1, 2, -3, and that's our proposed. We will note, I'm not going to do it here, but we will note that need to check in all 3 original equations. Of course, we're going to want to check our answers. That's a lot of work. We used over a full piece of paper. It took some time, and I have good news for you. We are not going to solve these by hand. So there is a way to solve these by hand. You just saw me do it, and that's the only time I'm going to do it. Okay, we're all done solving these by hand. We're going to use technology. Okay, so this method works, but we have technology. So we're going to solve these. We're going to learn in future videos how to use matrices, or a matrix is the singular form, matrices is plural. Matrices are available with your calculators, and we're going to learn how to use matrices to solve these in a simple keystroke as opposed to doing all this work, and that's coming up.